Iapetus, the most mysterious moon in the solar system. Raise your hand if you've never seen the timeless masterpiece of cinema known as 2001: A Space Odyssey. I don't see any hands waving, so okay, we all know what we're talking about here. We all remember the spaceship Discovery sent to Jupiter to contact the mysterious black monolith found on the moon and then pursued into the Jovian system. Well, that was the movie. But perhaps not everyone knows that alongside the screenplay agreed upon with Kubrick, while the scenes were being filmed, the writer and scientist Arthur Clarke also wrote the novel of the same name with a rather different plot. In the book, the Discovery is called to investigate the Saturn system, not Jupiter. And the mission's destination is not Europa, Jupiter's large moon, but guess what? Iapetus, a small moon of Saturn. This choice was due to the aura of mystery that still surrounded an object that had been baffling earthly observers for over 3 centuries by 1968. Clarke was aware of this and chose to set the ultimate encounter between humanity and the unknowable truth of the universe on that remote moon. But what exactly is Iapetus, and what do we know about it today? Let's find out with this exciting video prepared as usual for you by the Insane Curiosity channel. With a diameter of 1,470 kilometers, much less than half that of our moon, Iapetus is still Saturn's third largest satellite and one of the most distant, orbiting at about 3.5 million kilometers from the planet. Among Saturn's major moons, Iapetus also has the highest orbital inclination, over 15 degrees compared to the average of 1.5 degrees for the others. Due to this distance and its inclined orbit, Iapetus is the only large moon from which Saturn's rings would be clearly visible and recognizable as such. From the other inner satellites, the rings would be seen edge-on and thus different to discern. But the most surprising feature of Iapetus is the incredible difference in surface reflectivity between its two hemispheres. One hemisphere is very dark with a slight reddish tint, reflecting only 5% of the sunlight. The other is as bright as you would expect from an icy moon, with an albedo of 50%. Overall, the bright side is more than 5 times as luminous as the dark side. Interestingly, the two parts are divided in a pattern similar to the two halves of a tennis ball, or the famous Taoist symbol of yin and yang. This peculiarity was first noticed in 1671 by its discoverer, the Italian astronomer Giovanni Domenico Cassini. He realized that although Iapetus orbited Saturn just like other moons, it was visible only when it was to the right of the planet, remaining completely invisible when it was to the left. Believe it or not, after a period of great perplexity, Cassini himself hypothesized that one hemisphere of Iapetus must be intrinsically much darker than the other. However, proof was lacking, and for centuries this remained one of the deepest mysteries of observational astronomy. It was only partially resolved by the Voyager probes over 40 years ago, which revealed that Cassini was right. Iapetus' surface is divided into 2 hemispheres, as different as day and night. The 2 parts actually divide in a pattern similar to the 2 halves of a tennis ball, embracing each other. Like almost all other moons, Iapetus orbits with the same face always turned towards Saturn. This means that one hemisphere, called the leading hemisphere, always faces the direction of its orbital motion, while the other, called the trailing hemisphere, always faces the opposite direction. Now, the fact that the leading hemisphere is the dark one raises more than a suspicion that the cause of the darkening might be some carbonaceous organic substance that Iapetus encounters along its path. It's a bit like when your car windshield gets covered with dirt and insects. It's just a vague clue for now, but confirmation would come later. Meanwhile, astronomers have tried to explain the cause of this dichotomy with some of the strangest theories. Some suggest that the dark material might come from an internal source, possibly brought to the surface by a combination of meteoritic impacts and volcanism. This theory is supported by the apparent concentration of the material at the bottom of craters, similar to substances found in some meteorites or on comet surfaces. The thickness of the layer is not known for sure. There are no bright craters on the dark hemisphere, so if the dark layer were thin, it would need to be continuously renewed. Otherwise, a meteoritic impact would penetrate beyond the surface layer and reveal the brighter underlying material. An alternative theory suggests that the moon acts like a kind of snowplow in Saturn's system, collecting clouds of dusty debris on the surface of its leading hemisphere as it orbits, which would lower its surface albedo. If you've ever driven your car on the highway through a swarm of insects, these views of Iapetus might bring back some visceral memories. Since only the leading hemisphere, analogous to your car's windshield, collides with the matter directly in front of it, only one side gets covered in insects. Of course, there are no insects in space, but besides Saturn's main rings, there must be something else outside that acts as a source of pollution. And according to most experts, another moon might be responsible for it all, the very distant and tiny moon Phoebe. Phoebe is unusual in several respects. Unlike the other satellites discussed here, it is an irregular moon, meaning it did not form from an early disk of material as the regular Saturnian satellites are believed to have done. Instead, it was initially a freely orbiting member of the Sun's family that became ensnared in Saturn's gravitational net and captured by the giant planet. It is by far the largest of Saturn's irregular moons and travels around the planet in a retrograde orbit, some 8,043,563 miles or 12,869,700 kilometers away, taking 545 days to complete a single revolution. It rotates about its axis every 9.3 hours, is almost spherical in shape, quite heavily cratered, and has a relatively high density of 1.6 times that of water, indicative of a rock and ice composition. The surface of the moon is very dark and is covered by a mixture of water ice, frozen carbon dioxide, phyllosilicates, and organic compounds. There is a possibility that iron-bearing minerals also add to the mix. When the first long-distance space probe images of Phoebe were received, one astronomical writer commented that what was being observed was probably the encrusted nucleus of a giant comet. That seems not to have been too far from the truth, as most astronomers believe that prior to its capture by Saturn, this moon was a centaur or a Kuiper Belt object. The close-up images of this object provided by Cassini may have given us the best likeness of Chiron and its siblings that we are likely to see in the foreseeable future. Phoebe is now known to be associated with a faint ring, which in terms of diameter is the largest in Saturn's ring system. This ring is composed of dark particulate matter, believed to have been ejected from Phoebe's surface by meteoroid impacts. Hey guys, just a moment before we continue. Be sure to join the Insane Curiosity channel. Click on the bell, you'll help us to make products of even higher quality. This free-floating material from Phoebe's dark surface helps solve the mystery of the two-faced Iapetus. Like Phoebe itself, the particles thrown up from its surface orbit Saturn in a retrograde direction, gradually spiraling inward toward the planet. As Iapetus follows its direct orbit around Saturn, it sweeps up these particles with its leading hemisphere. However, the full story of Iapetus's dark hemisphere is not just about being covered by Phoebe's debris. The situation is a bit more complex. Being dark, this material absorbs sunlight more readily than lighter-colored materials, converting it into heat and raising the surface temperature of the regions blanketed by Phoebe's detritus. This leads to a thermal runaway process where ice evaporates, exposing darker material underneath, which then absorbs more sunlight, and so on. The result is that ice evaporates from the leading hemisphere and recondenses on the trailing hemisphere, increasing the reflectivity of the latter while darkening the former, creating the extreme contrast in reflectivity and color that we observe today. Apart from the remarkable color difference, there is little to distinguish the leading and trailing hemispheres of this moon. The entire surface appears ancient, heavily pockmarked by impact craters, and devoid of any obvious signs of volcanic activity past or present. The only really odd geological feature is an enormous 12.5-mile or 20-kilometer high equatorial ridge spanning much of the moon's circumference. Along the roughly 800-mile or 1,300-kilometer length over which it can be traced, it remains almost exactly parallel to the equator within a couple of degrees. The presence of this ridge gives the body a strange appearance, often likened to that of a walnut. The ridge contains some of the loftiest mountains in the solar system, reaching over twice the height of Mount Everest. But even this comparison scarcely does justice to the extreme elevation of this feature. The Earth is nearly 8,000 miles in diameter, Iapetus is just 919 miles. Mount Everest is a little under 0.0007 times the Earth's diameter, but the altitude of the Iapetan equatorial ridge is a full 0.014 times the Moon's diameter. Proportionally speaking, Everest would need to be around 109 miles high to equal the equatorial ridge. The reason why Iapetus has such a feature is not understood. Some researchers suggest that the ridge might be a remnant of the oblate shape of a rapidly rotating youthful Iapetus. This hypothesis suggests that early in its life, heating by short-lived radioactive isotopes such as aluminum-26 caused this ice rock moon to be in a more plastic state. If it was both plastic and very rapidly rotating, the moon may have deformed into the famous walnut shape before the decay of the heat source and consequent cooling set it into that form. Another hypothesis sees the ridge as due to the upwelling of icy material from beneath the surface, while yet another postulates the collapse of an ancient ring around the moon, depositing material along the equatorial zone. Another variation of this theory suggests that Iapetus once had a moon of its own, a satellite of a satellite, which over time spiraled in towards Iapetus before eventually disrupting and crashing to form the Great Ridge. The ring hypothesis is probably the least likely explanation, as material from a collapsing ring seems inadequate to build a ridge of the required elevation. Evidence of tectonic faulting through the ridge, not commonly seen on Iapetus, suggests that the formation of this feature was more likely driven by internal rather than external forces. But the weirdness doesn't end there. Iapetus has another claim to fame. It has some of the biggest landslides known. Evidence of slides known as long run-out landslides or STIRS storms, some 50 miles or 80 kilometers long, has been found along the crater walls and other slopes of this moon. Their height-length ratio initially puzzled planetary scientists. The landslides of Iapetus sometimes traveled as far as 30 times their height. By comparison, landslides and avalanches on Earth seldom travel more than twice their height. Ice was suspected to play a role in the length of these slides, but experiments with icy mixtures on Earth still failed to match the scale of these events. Somehow the ice on Iapetus acted as though it had a lower friction coefficient than the familiar ice of Earth, allowing ice-rock mixtures on this moon to travel greater distances before stopping. Is there something weird about the ice of Iapetus? Probably not. The most likely hypothesis involves ice melting through friction. Friction between the sliding material and the surface generates heat. If the sliding material is composed of both rock and ice, and if the frictional heat is sufficient, pieces of ice will melt, causing the debris flow to become more fluid and travel further than one composed entirely of solid particles. To complete the scenario, an ancient 400-kilometer wide or 250 miles impact basin appears just above the ridge. The basin is heavily overprinted by more recent, smaller impact craters. The basin rim is delineated by steep scarps that descend to the basin floor. Many of these scarps, as well as the walls of nearby craters, appear bright, probably due to exposed outcrops of relatively clean ice. According to some, this devastating impact may have had something to do with the formation of the long equatorial wall. But this is only speculation, and it will probably be decades before Iapetus decides to reveal its secrets. It will take a dedicated mission, a new discovery, to search for the gateway to the stars on this small moon, just as Arthur Clarke intended.